Hi everyone, this video is part 5 of the sensation and perception unit. This is called the other senses because we will do an overview of the senses that weren't previously covered. So in earlier videos we covered vision and audition or hearing, and this video will give an overview of the other senses like smell and taste, somatosensory, which is touch, vestibular, and proprioception, which is also called kinesthetic. So we'll go over some of those other senses in an overview. So to start with is touch. This is your somatosensory sensation, and this is picked up and detected by your skin. So there are different types of skin sensation or touch. We have the feeling of pressure, pain, temperature. There's also variations of those like a tickle, an itch, and wetness. We can all detect those through our skin. One theory that you'll have to know that corresponds with your sense of touch is the gate control theory. And the gate control theory relates to pain. So if you have ever been in a situation where you have felt pain and then you've applied pressure or a cool sensation or something hot, sometimes you have this feeling of alleviated pain, as if the pain has gone away. And the gate control theory attempts to explain why that occurs. And the gate control theory is simply that a non-painful input or a non-painful stimulus like pressure or temperature will go first through the nerve to the brain, and it's as if it closes the gate to the painful input. And so that pain sensation is slower or blocked from reaching the nervous system. So in the diagram, you can see how the sharp pain is being blocked because the pressure sensation is going first. So there's this little toll gate there to give you a visual of this gate control theory. It's as if this non-painful sensation has gone first and blocked the pain from going through that nerve to the brain. And so that's the gate control theory. The next slide goes over our brain and how our brain is perceiving and processing touch. So on the left side, you have a brain here at the bottom of this diagram, and it is showing you this blue sliver right here, which is the somatosensory cortex. The somatosensory cortex is on the parietal lobe, and here this sliver has been taken out and it's been displayed up here in a larger view so that you can see how all of the different areas of your body where there is skin and there is this feeling of touch or this feeling of pressure or pain, it's represented on the somatosensory cortex where it's being processed. And you might notice that there are some parts of your body that have more surface area on the brain, like your lips, for example. Your lips are taking up more surface area here than like your armpit. So we have more sensory receptors on our lips, and it takes up more surface area on our brain than, our forearm. And that just shows you how much more sensitive some of those areas are in your body to touch sensation. This is a diagram. It's an image on the right. The name of this is the homunculus man, and he is a representation of if our body were proportionate to our sensory receptors, then this is what our body would look like. And so you can see how the proportions of the hands are much greater and larger than like the shoulder or the elbow because there is more sensitivity to touch in those areas. The next section is taste. So you can see taste on the left is taken in through the tongue. It's also called gustation. You can see that there are these pores that are across the tongue, and inside of that pore you've got this really large taste bud. And this taste bud you can see in a better view on this center picture. This picture is a good picture because it talks you through that process, how whatever you're taking in, whether it's food or drink, will come across this pore. It will be taken in. It will be processed by these receptors. And you can see on this right-hand side, there are different taste receptors. Sweet, umami, which is a savory taste, a taste that you would find in meat. Bitter, salty, and sour, and that is receiving and detecting and taking in those tastes, and then it's being sent on to the brain. The next sensory, the next sense that we will discuss is smell. Smell is also called olfaction, and this is just really brief what you need to know. As the chemicals in the air are moving through your nasal passage, they are getting caught up here and are being taken up by your olfactory bulb, which is where transduction is occurring, and then it's sent on to the brain. And that is all you need to know for smell. The next is your body sensations, like your vestibular sense and your kinesthetic sense. Your vestibular sense is your sense of balance. I think that's easy to remember because vestibular has a B in it. So vestibular is balance. This is detected in your vestibular system or your semicircular canals, which are just above your cochlea in your ear. These are fluid-filled canals that move with your head and body movement, and that detection is sent on onto your brain to help you perceive and understand your orientation and if you're upright or if you're offset, and that helps you understand your sense of balance. Your kinesthetic sense is your awareness of your body and your body parts. So I like this image because you can see in this image, this person is both taking in visual understanding of where his body is. So he can see his hands and he knows where his hands are because he can see them. But if he were to close his eyes, he would still know where his hands were because of his kinesthetic sense, because of just his muscular system, the compression of the muscles and joints, and his awareness of his body parts is still there through his kinesthetic sense, even when his visual input is not there. Okay, so the next slide is about sensory interaction. This is when your senses influence one another and influence your perceptual experience. So you probably know this with your sense of taste and smell. You've probably had this occur if you've ever been congested and you have difficulty smelling. Sometimes that impacts your ability to taste because usually your eating experience is actually a combination of smelling and tasting that food. And so there's that sensory interaction of your sense of smell and your sense of taste. There are other situations where your senses influence one another. One of those is called the McGurk effect, and I'll let this video explain the McGurk effect. Okay, so that was the McGurk effect. So we have in our next section, whenever we are perceiving something without the actual sensation. So the first one is the phantom limb sensation, and this is where someone is feeling or perceiving that they are having a sensation when they are not, because they have had an amputation or a missing limb. And this usually occurs between 80 and 100% of people who are amputees, and so it's very, very common, but a small percentage of those will have painful experiences, and this just occurs because of after the situation has occurred, there's just an adjustment period of these unpredictable different types of sensations that are coming in through the nerves, and they're getting mixed and misunderstood signals, and so they're having a feeling in that limb even though the limb is not there. The next one is tinnitus, and this is the perception of noise, and it's typically ringing in the ears, and when there is no ringing occurring outside of the ears. And this is not a condition itself, it's usually a symptom of another condition, and it's typically associated with hearing loss. The third one is called synesthesia, and synesthesia is where there is a stimulation of one sensation, and this leads to the perception of another. And so this will occur in someone where whenever they see, it could be all kinds of things. So maybe they are having a connection between their hearing and their sight. So maybe they hear a note and then they see a color in the sky, or maybe it's their taste and their sight. So they taste something and then they see something in their visual field. And I know this sounds strange to someone who does not have this occur, so I'll show you an example of this, but the definition is when there's a stimulation of one sense and it leads to the perception of another. So here's an example of a person with synesthesia to help you kind of get a better idea of how this occurs.
My name is Caitlin Hova. I'm a software engineer, neuroscientist, and a musician. I also have synesthesia. Synesthesia is a blending of the senses. 1 in 23 people have a form of it. For me, when I hear specific musical notes, I see specific colors. And these colors are much brighter at night. What you're seeing in front of me is a lot like what I see when I hear this music. Each one of these colored lights corresponds to a particular note, and the colors are always the same. I've seen these colors my whole life, but I didn't know that was unusual until I was 21 years old. It was the final music theory course for my music major, and at the end of the class my professor mentioned that some people can physically see sounds as colors. And to me, I thought, duh, and everyone in the classroom turned to look at me. We did tests where they played notes on the piano, and I told them what color it was. And at that point, I knew I had synesthesia. Synesthesia can manifest itself in so many different ways. It can blend together vision, taste, smell, sound. It can be almost anything. But for me, it's always been about the colors and the music.
Okay, so hopefully that gave you a little idea into what it's like to have synesthesia. So in this video, we covered the senses that were not previously covered in the previous videos, and we just got a brief overview of those. I hope it was a useful experience for you. Definitely reach out to me if you still have questions.